Review. The quiz is 35 questions this week. So
Uh-huh.
we figured we would just get started right on the quiz.
Okay.
If
Yeah, that's
that's
okay.
okay with you.
Yeah, that'll be good.
All right, cool. So when everyone gets pulled up, we'll get started.
Okay.
Okay, I've got it up.
All right. So number 3, which of the following variables is R categorical?
This is like exactly the same as the homework, huh?
The prep, yeah.
Okay.
So this one would just be randomly selected brand of toothpaste because number of animals in the zoo would be,
That's a quantitative.
it's quantitative because it's numbers, not types.
Yeah.
Yeah. Same with the age of years, right?
Yep.
Yeah.
Okay.
One down, 34 more to go.
So I'm trying to remember on this. Well, I guess that's the whole question. Is the statistic the one that the original where they took everyone and then, or is that the parameter?
I don't remember here.
Yeah, I don't either.
Let me pull it up. A parameter is a true but usually unknown number that describes the population. A statistic is an estimate of a parameter obtained from the sample.
Okay. So the parameter is 112, right? Because it's taken from the sample, maybe?
So a statistic is an estimate of a parameter obtained from the sample.
Oh,
Yeah.
So
I don't know.
It's a little confusing.
Let's see here.
So 20 randomly selected statistics students took an IQ test, and their mean score was 112. So the 112 is from the sample. So 112 is the statistic, 100 is our parameter.
Okay.
Is that right? I don't know.
I think so because the parameter, it's like this is the mean for pretty much everyone in the United States, right? So the
Yep.
parameter around that, and then our statistic, we took the mean from 20 statistics students from that gigantic population of the United States,
And so
which would make it.
20 would be the sample, so 112 of 20 would make it the statistic.
Yeah.
That sounds right. Yeah.
So I clicked on 100 is a parameter, and 112 is a statistic.
Yeah, that's what I got too.
And
Okay.
if we get it wrong, we know it's the opposite.
Yeah.
Yeah.
uh, so is this just simple random sampling?
I think so because you just take it from that population.
Yeah.
hmm
What one is systematic sampling? Remind me of that one.
Systematic is every kth per item in
Okay.
the population beginning at a random starting point. So it wouldn't be that.
Yeah,
Yeah.
okay. I just can remember that one. All right.
So is this a cluster sample?
Just about to look up. Because it's a group, we're grouping it together.
Yeah. Because I mean, the definition of a cluster is all items in one or more randomly selected clusters or blocks.
Yeah. I think it's cluster sample.
Okay.
Because the only other one that might apply is stratified random sample, but they're not doing a simple random sample after they divide them up, so I think it's cluster.
Yeah.
Yeah.
At first, that's what I thought too. It might be stratified, but yeah, it's cluster.
So this one just seems
Oh, this one might be cluster as well, right?
no,
Would that not be?
I don't think
I don't
so.
think so.
I think this might be simple random sampling.
That's what I was thinking too, just because
Everyone in the population just randomly drawing names.
Yeah.
because it's not stratified, it's not systematic.
It's got to be a SRS.
And voluntary response sample, that doesn't even exist, does it?
Not really.
I don't remember learning about that one.
Yeah, it's not on the list of study stuff. So
Okay.
I'm going to go with SRS.
Simple random sample.
Yeah.
Okay.
So this one would be the, what is it, stratified?
Yeah.
So they're dividing them into groups and doing a simple random sample of it.
Yeah, it's stratified.
Yeah.
Especially since they're dividing them into such similar groups, like specific for each group.
Yep.
Democrat and Republican.
And yeah, I think the key is they're doing it, dividing them up, and then they do the simple random sample, and that's the only one who does that. So.
Okay.
All right, so this is where we have to have the SPSS opened up.
Okay.
9 through 11. All right, so I got a mean of 4.77.
Yeah, so did I.
I'm gonna agree with you guys because I don't have SPSS. I'm sorry, I'm useless in the morning.
No.
And then standard deviation is 1.912.
Yep, that's what I got too.
9.12.
1.912.
Yeah, the histogram makes it pretty simple on those
It really
ones.
does.
Okay.
So 11, I created histogram to do this.
Yep.
So this is like exactly what we did a few weeks ago with one of the case studies and one of the assignments.
Complete the following table. Oh, yeah, I remember.
So let's see if I remember right. We find the mean of all those and subtract this from the mean, right?
Yeah.
So for the mean, did you get 38.075 for the first part?
Yep. That's what I got.
Yep, me too.
So then we minus 37.91 from that, right?
Yep.
Mhm.
So negative 0.165.
Yeah.
Is that what everybody else got?
Yeah.
So then for B, I got 0.681.
Yeah, that's right.
So to get that, you just minused those and then you square rooted it?
Yep.
Yep.
Well, you don't square root it.
Well, not square root.
But you
Whatever.
square. Yeah, you square it.
Square it, that's what it's called. And you said you got 0.681.
1 when you round it.
Mm-hmm.
Okay, yeah, that's what I got. I wonder if on the test she's going to have that little chart there that tells you how to do it.
Yeah.
I mean, it's pretty easy to remember, but I don't know, that'd be nice.
Yeah.
Okay.
So what quantity is equal? So what do you guys think for 14? I don't know. I don't know.
I'm still doing it.
Yeah, me too.
Oh, it's probably. Hold on a second.
It's not mean, right? And not. Do you know what variance is?
0.62. Oh, I don't know. Well, if you add both of them up, the deviation from the mean and the squared deviations. Oh, well, maybe not. I don't know. They're really close to the same number. To find the variance, don't you take that number we square rooted it, and then that we square rooted, and then you divide by something? I gotta look this up again.
Yeah, that's what I'm trying to find is variance because I don't think it's the other ones.
We learned about it in lesson 3.
Okay. Oh, there it is. So that number we found, after you add them all up, isn't it 1.5341 from that square rooted area? If you add them all up.
I've got one more to do still, actually.
And then once you do that, 1.5.
Yeah, I got 1.779.
Oh.
So that would be the sum.
Did you just round them when you got those?
Yeah, that was doing it from the rounded numbers.
Okay. Hmm. I'm not sure on this one.
Yeah, I got 1.534.
Yeah, so did I, but that's
Yeah.
just not rounding them. That's why.
Yeah.
Um. Hmm.
So yeah, so you square the deviations, then you add up the squared deviations from the mean, which is in the third column.
Mm-hmm.
Then divide the sum of the squared deviations by n minus 1. Write this value in the bottom of column 3. So I think that's the variance.
N
What
minus.
is n? Oh, sorry, Sean.
That's your sample. So n's your sample size. So
Okay.
n minus 1. So this would be the number divided by 3. The variance would be, I got 0.593. And then you take the square root of the sample variance to get your standard deviation. And so I got that as 0.770. But I think I made a mistake because I put these numbers into SPSS and I got a different standard deviation.
Oh.
I got a standard deviation of 0.715, and I got this by hand as 0.77. But also the mean in there is 38.08, and I used 38.075. So it makes sense to be a little different, I guess.
Oh, yeah.
What did you guys get for it?
So for which one? Sorry, I was looking up the SPSS part.
So were you able to calculate it clear out to the standard deviation?
So I was trying to figure that out because you take the sum, right, of the square rooted, or not the square root part, the squared part.
Uh-huh.
So I was looking back on the book, and it showed.
So yeah, you sum up your third column, and that creates your sum. And then you square your sum, and that gives you your variance.
Oh, then you square that.
So my sum, I know you guys got a different one. I'm not sure why we're getting different numbers, but my sum was 1.779.
Yeah, so we got 1 point. We just didn't round them. That's the reason why. So then
Yeah, I'll do it again.
2.35. And then you said after that, so you get the sum square rooted equals the variance. And then what, how do you get to the standard deviation from there?
All right, so yeah, step 4. So you create your sum. So now add up the squared deviations from the mean. That creates your sum. Step 5. Oh, so I told you wrong. So step 5 is divide the sum of the squared deviations by n minus 1. So you take your sum,
Okay.
divide that by 3.
Why by 3? I'm confused on that part.
Because it says divide the sum by the square deviations by n minus 1. N is your sample size, and there's 4. Our sample size is 4, so n minus 1. So 4 minus 1 is 3.
Okay, yeah.
That makes sense.
So you divide the sum by 3.
What does that give you guys?
5, 3, 4, 1.
Was that what you got the first time, to 0.59?
I got 0.593.
Yeah.
I got 0.5113 66667.
Yeah.
Is that what you got, or did you guys get the?
That's what I got. This 2 on mine. 0.511. But I don't know why I'm.
Okay, I think you guys are doing it right because when you do the next step for yours, you get 0.715, and that's what I got with SPSS also.
What's the next step after that?
So then the last step is you square root your sample variance.
Okay. And then you guys got 0.715. Is that what you said?
When you do your numbers, you get 0.715, and that's what matches up with the SPSS.
Okay, because that's what I just got.
Yeah. Me too.
So the 0.715 is the answer to number 15.
Sixteen's true.
So, but what should we do about 14?
Oh yeah, we never answered that, huh?
Oh boy.
Are any of those correct?
There we go. What did you guys say you had for 15? Was it the 0.715?
Yep.
Yeah.
Sorry, my computer froze.
That's all right.
16's false, right?
No, 16 is true.
Oh, it can be?
Oh. No, it is false. The Z number can be
Negative. Standard deviation has to be.
standard deviation is always positive. You're right. I didn't
What?
think
Yeah.
I didn't think that sounded right, but I'm tired.
Yeah. Yeah.
Did you guys for 14? Did you guys get an answer for that? I missed it.
Yeah, I'm not sure. So the quantity is equal to the sum of numbers in the squared deviations column. What does that mean?
So if we add all of those together, that number is supposed to represent, or it's supposed to be equal to one of those options,
None of them
but
makes
it
sense.
wouldn't be the mean.
So would it be none of these are correct?
And we have our standard deviation down below, and it wouldn't be that. So
And it's not the same as the variance, so I think none of these are correct. I think we should go with that.
yeah.
Yeah. All right.
All right. So extradural would be 17, right? Because that have the smallest standard deviation.
Yeah.
So which is the result of the most, because of the smallest standard deviation, that gives you the most accurate, right?
Yeah, it'd be the most consistent numbers. They'd be the closest together.
Yeah, because it doesn't deviate far from the original or the one number, whatever it's called.
Those sample sizes wouldn't matter, right? Just as long as the standard
No, I
deviation.
think the sample size would matter a little bit, but I mean the standard deviation is so much bigger on those other ones. I don't think it would be
Yeah.
significant.
Yeah. Okay. 18 is true.
Yeah. Put false on that. Sure would be good. On 19. So I get so confused with this little barn whisker thing. I remember learning about this in like elementary school, and I think I understood it better then than I do now.
So the main box represents your first quartile, median, and third quartile.
So median is 6.
Yep, and third quartile is 8.
Okay. What percentage?
I don't remember this.
Huh.
Would that just be the percentage out of 10? So if there's, for example, 4, would that be looking 4 out of 10? So would that 40%?
Would it be 6? I got 67%, but I probably did it wrong. Oh no, yeah, you're right, because it's 10. It's starting from 2 to 12. That's 10. I'm sorry.
Oh, it's okay. I could be wrong. I'm just kind of
So would it be
guessing,
40%?
looking at.
That's the correct way. I got 40% too, which makes sense. I mean,
Yeah, because that whole box plot would show everything, right? For everybody tested, and then
yeah. So there's,
we're at
I mean, in between there's 4 hours, there's 10 hours total. 4 divided by 10 equals 40%.
So the first quartile is 4. Everything below that's 25% of everything.
Mm-hmm.
And
Okay.
then the 8 is the third quartile, which is 75%.
Oh, you're right. Yeah.
So that'd be 50% of information is between that, right? Because there's
Yeah.
25% below and 25% above.
Yeah. That actually makes sense now. I remember.
Wait, so from 2 to 4, there's 25%, is that what you're saying?
I think so.
And then from 8 to 12,
Yeah.
there's 75%? Or no?
Well, with the quartiles, I mean, it's 25%.
Mm-hmm.
25.
So the first quartile, there's 25% below it, and then the third quartile, there's 25% above it.
Yeah. Sorry, I did it wrong. Yeah.
So what's the answer to that?
So it'd just be 50, right?
I think so. Give me 1 second here. Okay, so yeah.
Mm.
Yeah, because in week 1, lesson 3 homework, we had the same exact box thing with the same exact question. It says approximately what percentage of data lie between 4 and 8 hours, and it's 50%.
Yeah.
Could you
Yeah, that makes sense.
could you explain that to me again? I'm
Of course.
lost.
So this box thing has to do with all percentages. So the first edge, the 4, is 25%.
Okay.
25% of all data lies to the left of it or below it.
Oh, 25% of it lies below it. Okay.
And so number 8 would be the 75th percentile. And so 75% of data falls between it. And so since 75% of it data falls between that, and then so you can knock off 25% for that. 75 minus 25 is 50.
Okay. 'Cause that equals 75%. That's 25%. So in between those two, you just minus those two equals 50%.
Exactly.
All right. That just looks so weird because, like, how could that third quartile be 75% when there's so much more up to 12? Or is it just like?
And that doesn't mean there's numbers. That's just the outlier going way up there.
Yeah.
Ah, that's what I was getting
Yeah.
confused at.
Mm-hmm.
Awesome.
Yeah,
I
if this
understand.
an
Thanks, guys.
app that you'd left.
Okay, so what is that funky looking U thing? Is that the mean?
Yes.
And then the O, is that the observation?
No, that's
Mhm.
standard deviation.
Okay. Okay.
So I think what this is saying is 2.52 is 2 standard deviations away from the mean. But I'm not sure.
Yeah, that's
Yeah. Do we have to find?
the mean minus 2 times your standard deviation. Oh, maybe.
So that's the calculation. So mean minus 2 times standard deviation, or u plus 2 times standard deviation is equal to 2.52 parts per million.
Hmm.
Do we know what our standard deviation is? Or does it give that information? Or is that something we have to math out?
I don't know. I don't see it.
Yeah.
I have no idea.
Yeah, I'm confused on that too. I'm lost.
Because it says that the values outside of 1.59 and 2.52 are unusual. So we know that that's 2 standard deviations right there, but I don't know which number it's wanting to talk about. Or I guess it's 1.59 maybe, because it says right after we assume that.
So it's just trying to estimate the mean.
Uh-huh.
1.59. So it's 2.055.
Okay, so what they're saying here is we assume that 1.59 is the value of u minus 2o. So u minus 2o equals 1.59, and u plus 2o is equal to 2.52.
Oh, so then we just got to figure out.
So we got to figure out whatever number is in the middle of that, because whatever it is, when you take the mean minus 2o equals 1.59, and the mean plus 2o is 2.52.
Would we just add them together? Oh, wait, no.
So we have to figure out what u is and what o is.
Yeah.
Do you guys know how to do that?
I'm
No.
looking in the book right now.
So, I mean, I could figure it out if we were just looking for one of them in the equation, but I don't know how to figure out for two.
So we know that 1.59 would be the negative 2 standard deviations, and the 2.52 would be as high as the positive 2 standard deviations go. So would we just minus 1.59 from 2.52 to find the range between those two standard deviations, and divide it by how many deviations there are?
So just to find the mean?
Yeah. Or this is a fine station.
Whoa, I don't know. I just lost you right there.
Yeah, sorry. That's kind of.
Say that again. Sorry, I didn't. It broke
Oh,
up.
yeah. I think I might be doing it wrong. Because
So I
I
did
think
it the really easy way. I just did 2.52. I added it by 1.59. Just did the mean of it and divided by 2. Which is probably not right, but
yeah.
So
that
what number do you get for that?
2.055. So it's just right in the middle of those two. But I don't think, I don't know, that seems too easy to me to be right.
That might be right.
So,
that I feel like that might be right, but I don't know.
really? I think it's asking more than that. I don't know.
Yeah. Well, it might make sense because just they're both equally different, because one of them's negative 2 deviations away and the other one's positive 2, and so
That's true.
And so we know it's 2 standard deviations. So if our mean is 2.055 minus 2 times 0.2325. Yeah, that's it, dude.
Is it?
yeah.
So what I did was you took the mean, which is 2.055,
Okay.
and I minused 1.59 from that, and that gives me 0.465. But it's 2 standard deviations, so I just divided that in 2, and that gave me 0.2325, and if I put that into the equation, it gives me the numbers.
That's what I got too.
Oh, really?
So I think that's right. Yeah.
Well, great.
And if I do it the other way, I get 2.52, so
Yeah.
Awesome.
so the mean is 2.055,
Yeah.
and the standard deviation, rounded to 3 decimal places, is 0.233.
That's what I got as well.
So, sorry. So to get that standard deviation, just did 2.055 minus 2.59. Let's see here.
Yeah, and that's right, because for question 23, it starts giving us the right answers for that, too.
Yeah.
Really?
We could have just looked down below the whole time.
Yep. So those are right,
Mm-hmm.
unless they're trying to trick us, but I don't
Yeah.
think so.
So
Yeah.
you guys got the standard deviation of 0.233, correct?
Yep.
Okay, awesome.
Yeah.
I was just making sure I could do that right. Wait, so what's 23?
23 is the last one. 1.822 and 2.288.
And sorry, I missed that. How did you get that? You just
So we figured 22. The standard deviation of 22 is 0.233. So if you take your mean and add 0.233 and subtract 0.233, it gives us 1.822 and 2.288.
oh, okay.
What's 24 looking for?
I have no idea.
Yeah.
Pretty
I'm
sure
gonna have
that's
to look
what we
this.
just barely learned.
Yeah, I'm not sure what they're asking for this one.
Yeah. Because it doesn't pertain to the previous questions, right?
Yeah, well, the previous, it says, just goes
The
to
20.
21 and 22.
Yeah.
What is the value of the mean of a standard normal distribution?
Yeah. The, yeah, it's just weird because it doesn't give any information to base it off of.
Do you have any idea, Sean?
I'm trying to figure it out. So what is the mean of the standard normal distribution? So, oh, no, I was thinking deviation. Never mind. It's got to be something like simple.
Yeah.
It's got to be like 1 or something like that. I'm just trying to look it up right now. Hmm.
Oh, so what is the value of the mean of a standard normal distribution? It's 50. It's right. It should be middle.
Oh.
Oh, because it's got to be 100, right? 100%?
Yep.
Or 100, yeah.
And so what is the value of the standard deviation of a standard normal distribution? A standard deviation then would be 1, wouldn't it?
Yeah, well, a normal one, I guess, would be.
I don't know if that's right, but
It sounds right. I'm
Mhm.
trying to find that. There we go. I think I found it.
Would we have to type in 50% on number 24?
So it says when the mean of a normal distribution is 0 and its standard deviation is 1, we call it a standard normal distribution. What does that mean?
No idea.
Is it asking what the standard deviation or like the z-score would be basically? Because if a z-score is 0, then that's where the mean is as well. But I don't know if it's asking for the z-score or what.
I have no idea.
It says a standard normal distribution has a mean of 0 and a standard deviation of 1. The 68, 95, 99.7% rule states that when data are normally distributed, approximately 68% of the data lie within one standard deviation from the mean. So it says that the mean is 0, but I don't understand how that is.
I think that makes sense if that's what they're talking about z-score, but it doesn't mention that. That's why it's kind of confusing.
Well, your mean can't be 0 though.
Which is what I was thinking.
It's between 0 and 1.
Mm-hmm.
Well, I guess. Well, the mean is the middle of your numbers, basically.
Mm-hmm.
Yeah.
Well, it is. It's
Well,
the exact middle of the numbers because the mean you add everything up and divide by the number.
So I guess it could be 0, couldn't it? If you have negative numbers. Standard normal distribution. I think I get what you're talking about, Joe, because you got your two z-scores. One of them's negative, one of them's positive. If you try to get the mean of those, it'll come up to 0, right?
Yeah. Yeah. Unless it's talking about the probability number. That's what's kind of weird about this question. It's not asking for like the probability or the z-score. It's just saying something in general. But yeah, I don't know. I think it could be maybe 0, but
Well, I think
it depends, I guess.
I just don't understand why it's 0, because it says right here, a standard normal distribution has a mean of 0 and a standard deviation of 1. I mean, it's right there.
I mean, you found it word for word. Let's just go with that.
Yeah. Yeah, it must be talking about z-score because the z-score, if it doesn't deviate from the mean at all, then that would be 0. And so I think that's what they're looking for here.
I don't know. I don't want to. I mean, it's right. I guess it's right there. So.
Yeah, I think. I mean, that's what it says word for word, whether we understand it or not.
Yeah. Exactly.
So 24 is 0, 25 is 1.
Yeah.
Yep.
Okay. Well, I guess we'll gamble and see what it does for us.
Yeah.
We're almost done though.
Yeah.
Is 26 just 0.5?
So we have to find the z-score for it, right?
Yeah. Right. What is it? You have to find the z-score to find the probability.
Yeah, and then
with
just
the applet. Or no?
Yeah. Well, the probability, it's just asking if what the probability is if someone gets higher, if someone gets a score higher than the mean itself. So would that just be 0.5 because that has to be the rest of the 50%
Yeah.
portion?
It's 542.
Yeah, so I think we need to find the z-score and put it in the little calculator. But you're right. I mean, it says what is the probability that a randomly selected student will score above 542, and that's our mean.
Yeah. And the probability can only be between 0 and 1, and so would it just be 0.5?
Yeah,
Hmm. So, Joe, are you using like the 68, 95 percentile thing, 99 percentile?
Um,
You are?
no, I'm
yeah,
I'm
it,
I'm
it
just
would
looking
be
at the number.
it would be 50% because I mean your z-score is 0 because I mean that's your median.
Mhm.
So the question's asking what is the probability that a randomly selected student will score above it? So even if you go to your normal applet, put in that, it gives you 0.5.
Yeah.
We're supposed to round it to a nearest tenth, so it would be 0.5. It has to be. That's the only thing that makes sense because 542.3 is your median, so that means it's right in the middle.
Yeah.
Does that make sense to everybody?
Yeah. Yeah,
No.
that's what I was thinking.
Sorry. So you got your z-score from that? You just
So even if you put that in the formula, you would do 542.3 minus 542.3 divided by 120.54, and that gives you 0.
Mhm.
so
So I mean, if it's your median, we know that median is the middle.
yeah.
Exactly half of 542.3 will be below it, and exactly half of it will be above it.
Oh, I see. Which makes
Mhm.
50%.
So that's why you get 0.5.
That makes sense.
And so for the next question, 600, you get a z-score of 0.479 when you round it.
I got 0.684 on 27. Is that what everyone's getting?
I got a z-score of 0.479.
Yeah, because it's just 600 minus 543.2 divided by standard deviation, which gives you your z-score, correct?
Yep.
Mhm.
Is that what you got, Joe? Is that what you said? Sorry.
That's what z-score I got, and then to find the probability, I just highlighted the two boxes to the left on the applet because it's asking for who will score below 600.
Oh, I get what you're saying now. So
Uh-huh.
0.684.
Yep, that's what I got. Is that right?
Below 600.
So yeah,
Zero point-
that's what I got too. 0.684.
Yeah, that's exactly what I got.
Okay. Yeah, and then the next one was just asking for the.
Opposite. So I mean you're 0.316.
Mhm.
Oh crap. You said 0.316.
Yep. So 27 is 0.684. 28 is 0.316. Is that right?
Yeah, that's what I got.
Yep.
So find the GMAT score that corresponds to the 10th percentile. So we'd go to the normal probability applet and just type in 0.1, right?
I don't know.
Because your area, you would want to go to your 10th percentile. So if you type in 0.1, then just shade everything to the left. That would give you the z-score.
Yeah, that's right.
Oh, but we have to find the GMAT score, so that wouldn't really do it for us.
Oh yeah, yeah. I think there's an actual formula for this.
So calculating percentiles from normal distribution, I found it here. So first we need to find the z-score. Negative 1.28.
So how do you find the z-score for the 10th percentile? I don't understand that.
So you go to your normal probability applet,
Okay.
type in 0.1 in the area, and shade everything to the left, and that gives you your 10th percentile z-score.
So that's like negative.
1.282.
Okay.
I think there's an easier way to do it, though. Let me find my papers.
Oh, wait.
Do we just do that z-score times the deviation, and then you round that to a whole number?
Oh, so this one is... Okay, so this... Oh, okay, so I remember how this one works. Give me just a second to make sure I remember how to do it right. So yeah, this one, you do your mean plus your z-score, and that's times by your standard deviation.
Mm-hmm.
So you do your mean, so it'd be
542.3. So plus your z-score, which is negative 1.282. And that is multiplied by the standard deviation, 120.54. So 10th percentile would be 387.768.
Okay, so let me just repeat that. You said you do the mean, you add the standard, you mean the z-score, and then you do what? Then you times it by what?
So with what the symbols look like, I don't know if you kind of remember this formula. So you do your mean plus your z-score times standard deviation.
Times standard deviation. Okay.
You got 388.
I got 387.768. So basically 388.
Okay.
So,
It just says to round it to the nearest whole number.
okay.
But that's what I got as well. It's 388.
I'm going to put it in and make sure that our z-score matches. So we would do
Whoa, what did you guys get?
388.
Whew. I definitely did not get that.
What'd you get?
It was like 66,000 or something. I did something wrong.
Yeah, we did it right, so I don't know what you did wrong. So it'd be, yeah, rounding it to a whole number, it's 388.
Yeah,
So
I just checked back.
Okay, hold on a second.
Basically, the formula that we use to create the z-score, we're just reversing it around to, instead of solving for z, we're solving for the percentile.
So did you say, okay, so you got your mean, you add from the z-score.
So you take your mean, add your z-score, and then in parentheses, so it's u plus z parentheses standard deviation.
What's the standard deviation? Is it
120.54.
So help me out here. I'm going to tell you the equation I got, and I keep getting something way wrong. So 542.3 is our mean, right?
Yep.
Then you add our standard deviation, which is negative 1.282.
Yep.
And then you times that by 120.54.
But you have to make sure, if you're putting it all in one line, you have to make sure that the negative 1.282 times 120.54 is in parentheses. So it does that first before adding it.
Ah, that's what I'm doing wrong. I see. So let me see here. Okay, so did you show me an equation? Sorry, I wasn't even looking. I was just listening.
That's okay. So it's u. Here, I'll show you it again. I don't know how well that comes across on my camera.
Oh, it comes across good. I see. So I was doing u plus z parentheses the standard deviation. That's where I was doing it wrong.
So you just have to make sure your z-score multiplies by your standard deviation before u adds to it.
Okay.
So on the next one, the 90th percentile, that would just be the opposite. Well, the opposite. It's just finding the bottom half.
Z-score.
Yeah.
Oh boy.
But instead of having it as a negative, it's a positive. So we would do 542.3 plus 1 parentheses 1.282 times 120.54. So I got 696.8. So it would be 697 because it wants it rounded to a whole number.
Uh-huh.
So do you understand what we're doing now, Sean?
Kinda. I still got the wrong answer, which I'm so confused about.
So here, I'll walk you through this one with the 90th percentile.
Wait, before you do that one, for 29, what did you guys say the answer was?
388.
388. Okay.
And then for 30, the answer is 697.
That's what I got too.
Hey, let me try one more time. Ah, there we go. I got it now. I see. Woo, sorry guys, that took a while.
That's okay. Not a big deal.
Okay.
So 31, find the first quartile of the standard distribution of the GMAT score. So we'd find our 25th percentile.
Mm-hmm.
So this is just the exact same way, right?
So yeah, you go to your probability applet and the area pump in 0.25 and shade everything to the left, and it gives us a z-score of negative 0.674.
Yeah.
So the 25th percentile I'm getting is 461, rounded to a whole number.
You say you got 461?
Yep.
Awesome.
Yeah.
That's what I got too.
So now for the third quartile,
Just get the 75%.
yeah, it's the same
Yeah.
z-score,
Oh,
but
it is.
positive. So I got 624 when you round it.
Yep.
Yep. That's what I got too. That's not that bad. That's actually pretty easy.
All right, so 33. Consider a simple random sample of 15 students taking the GMAT. What is the mean of the distribution score for all the samples?
So this is where you take the z-score. Oh, yeah. This is where you get that funky z-score, right?
But so it wants to know what mean. We'd still use the same mean score, though.
Oh.
Mm-hmm. Yeah, that stays the same, correct?
Yeah, so the mean stays the same, so it's 542.3.
The deviation that changes with that.
It's the standard
one.
deviation that changed. That's what got us on the last week's one.
Yeah.
Standard deviation changes?
Yeah, because then you have to do the funky thing. Here, let me find the exact algorithm.
Is that just the mean divided by the
So you take your standard deviation divided by the square root of the sample size.
Okay.
So our standard deviation is 120.54 divided by
The square root of the sample size.
square root of the sample size.
I see.
And our sample size is, what was it, 15?
Yeah. Did you guys get 31.123?
Yep, that's what I got.
Is that what you got, Sean?
What did you say you got?
31.123.
No, I just did it wrong. Yeah, 31. 31.1? Or what is it? To the nearest?
It's to 3, so 31.123.
Okay. Yep. Wait, it says round to the nearest tenth, one decimal place. So wouldn't it just be 31.1?
On 34, it says to round to 3 decimal places.
Oh, well, what was 33? Sorry.
That's okay. 33, you just use the same mean, so it's 542.3.
Oh, that's what I was wrong. 542.3, and then the standard deviation is the 31.123.
Mm-hmm.
Okay.
And then for the last one, I got 1. Oh, wait, so the probability. So I got a z-score of 1.854.
Is that just asking for the area of the upper portion of that z-score?
So this is the one where we put in that really funky one where you do your number, so 600 minus your mean divided by your sample size divided by the square root of 15 that we were doing last week.
Yeah.
And so that gives you your z-score.
What's the formula again? It's the
So it's it's your observation or whatever. So in this case, it's the 600 minus your mean 542.3 divided by your standard deviation, right? Divided by the square root of 15. Correct?
Oh yeah.
Your z-score.
And that gets you your z-score, and then you put that in the probability applet, and I got 0.968.
Oops.
Oh, do we use the deviation that we just found out? Or do we use the deviation from the actual...
I think you used the deviation from the actual problem, right?
Yep, you do.
Oh, I used the deviation we just found.
You're not going to your class?
No, I'm not going. You guys got 1.853 or 4?
Yep.
Okay.
And then you put that in the probability applet, and that gives us the answer.
Okay. .032.
Oh, that's
So it should be 0.968. So it's saying basically I have a 97% of people will, oh, you're right, so greater than. So yeah, 0.032.
Okay.
I'm glad I looked at that closer.
wait.
Yeah.
Did
So
you
it's
guys?
asking what's the probability that it'll be greater than 600. So we find the z-score, put it in the probability applet, and shade only that little area to the right.
Okay, so did you guys get 1.854 for the z-score?
Yep.
Oh, so it's
Yeah.
0.0319.
I have to go to 3 decimal places, so that 9 will make it 2, so 0.32. 0.032.
Yeah. All right, I got that.
All right, I'm submitting it right now. And we missed one,
Ah.
I think. I got a 97%. I'm happy with 97%.
Yeah,
Yeah.
that's pretty good. I just hope that the test goes that way.
So we missed number 5. We thought it was a simple random sample, and it was a stratified sample.
Ah.
So, I mean, we missed an easy one and got all the hard ones right. So I think we should feel good about that.
Yeah.
Sample. So why is this one a stratified?
Yeah, I don't know.
So I guess they're dividing them up from the
I
low
guess they're
property.
dividing them into neighborhoods.
Yeah, the low property tax compared to the other.
So since it's divided up that way, that makes sense.
All right. Cool, guys. Well, thanks for your help.
So when should we meet
Yeah.
next?
Oh, I think I'm good Wednesday or Thursday.
Yeah, me too.
So my hard thing is I work tonight, and I have to take the test. I'll probably end up having to take the test tomorrow because I don't know how many questions it'll be.
Yeah, I'm taking it tomorrow too.
And so I think, and then I'm in class. I have a class at the hospital from 8 a.m. on Thursday, so maybe Thursday afternoon.
Sounds good to me. Oh,
4 o'clock, 5 o'clock, 6 o'clock, I don't know.
yeah, I think that should work fine with me.
Yeah, that's
What
fine
about
with me
you?
too. That's good.
So 4 o'clock, does that work?
Sure. 4 o'clock?
Yeah, Thursday at 4.
Yeah, that'll work.
Would one of you guys mind emailing Annie?
Sure.
Yeah.
I can do that.
Okay.
Okay, cool.
Okay.
Thanks, guys. We'll see ya.
Good luck on the test.
All right.
You guys too.